Hi, we're back at video 2 of separation techniques, and now we're looking at filtration, and we see filtration is used to separate suspensions. So let's recall what are solutions and suspensions. Now remember that a suspension is non-homogeneous, which means that you have an insoluble substance inside a liquid, for example, like sand and water. A solution, for example, like salt water, is homogeneous. And when left standing, the salt does not separate from the water, so it's homogeneous. Now, we are looking at suspensions here. So we are looking at separating the insoluble substances from the liquid itself. Now let's think about this question. Now, I'm sure some of you drink tea or coffee, or you've seen your friends or parents drink tea or coffee. So this is a normal Lipton tea bag. Now I like to drink tea a lot, but I don't drink Lipton tea, I drink green tea. But let's look at a Lipton tea bag. Now, some of you might say that there's nothing wrong with this tea bag, right? But if you look very carefully at a tea bag doesn't have holes. So why are the tea leaves stuck in the tea bag? But yet you have something coming out into the water. There are no holes, right, in the tea bag? But if you look very, very carefully, there are actually very tiny holes in the tea bag. Now these holes will allow what we call the tea particles to go through and dissolve in the water, but the tea leaves are then stuck. Now we know that the tea leaves did not pass through this tea bag, right, because it's still stuck there. But we do know that some of the particles have passed through because the water has turned brown. But important question as we look at this is, what can you say about the size of the tea leaves compared to all the tea particles that have passed through the tea bag? Now, hopefully, some of you might say that the size of the soluble tea particles will be smaller than the size of the tea leaves. Now, we will call the small holes in the tea bag pores, and the size of the soluble tea particles must be smaller than the size of the pores or the holes in the tea bag in order for them to go through. But the size of the tea leaves are much larger than the size of the pores in the tea bag, so then they are stuck in the tea bag. Now, I want you to write this down, for this is the principle of filtration. So those that are larger than the holes stay inside the bag. Those that are smaller than the holes go out of the bag. So we need to know some key terms for filtration. So first term we need to know is the term residue. Now in the case of the tea leaves in the tea bag, the tea leaves are the residue. They are things that are left behind. The thing that goes through is the filtrate. So in this case, it will be the soluble tea solution. Now, we must remember these two terms. So this is how we set out the apparatus. There is the filter funnel here, and we have what we call filter paper. Now this is not ordinary paper. Okay, it is filter paper with special small little holes in the paper. Now you can't see those holes. Okay, you'll get a chance to see the filter paper when you're in the lab as well. And we put the filter paper in the funnel and we collect it in a conical flask. So you pour it through a filter paper, and what is insoluble will be left there. So this is what it looks like on a particle level. Now this will be the diagram you're supposed to draw at the bottom of page 2. So when we pour something like, for example, sand plus water, So imagine these are the sand particles and these are the water particles. You're pouring them through the filter paper. Now the sand is too large to pass through the small holes in the filter paper, so they get stuck on the filter paper. So you see the brown residue here. But the water particles are very small, so they pass through the holes in the filter paper, and that's how you get the water as the filtrate, and that's how you separate sand from water. Now, the key concept of filtration, and I'll repeat again, is that the size of the soluble particles, in this case it is water, is smaller than the size of the pores in the filter paper. And the size of the pores of the filter paper is smaller than the size of, in this case, the sand particles. So this is why the sand remains as residue, but the water passes through as a filtrate. Now, if you were to do this in class, I have a volunteer, but now I have a mysterious volunteer here, and let's watch the video to see what he will be doing.
What we have here is a mixture of water and sand. Right? The blue balls represent water, the yellow balls represent the sand. Here's my filter. We're going to see how a filter works. The filter. So I'm going to look at what happens when we pour this mixture into the filter. What filter?
Now, so you realize that what is left. So if you notice, what is left inside the filter are the yellow sand particles, and what has all gone out of it are the water particles. Now I'll leave you to guess who my mysterious volunteer is. Now we go on to the applications for filtration. Now this is on page 3 of your notes. So let me tell you a story. So I lived in the United Kingdom for 4 years, and when we drank water in the United Kingdom, when I first went there, I had to use this. Now this is what we call a filter. It's used to filter water, but it's not like a filter paper. You can't actually see the filter. Now, why do we have to use a filter? Now, because in the UK, water is hard. Now, it's not literally hard like ice or anything. It is still water, but it's hard because it contains many minerals. Now, it is not mineral water. As you see, these minerals are actually visible, like white solids. So we have to filter out all these white solids so that we can drink clean water. Well, when I was lazy, then what would happen is that I would just boil the hot water without filtering it, and you can see that the metal has turned white. This is the clean metal. But after boiling it for a while, you see lots of white solids on it. So these are the minerals in hard water. Now, we used to joke that all these white solids will be in our stomach, and eventually our stomachs will be a white solid as well. So we won't ever find out unless you do an autopsy on me when I die. That's a too morbid a story to tell. So there are many applications for filtration other than filtering water. So in the table in your notes, can you look at these examples and write down what is the residue and what is the filtrate? So for the first one, for sieving vegetables, so obviously there are holes in the sieve. If you haven't seen one, do ask your parents to let you in the kitchen to see a sieve. So this is used to wash vegetables. So the residue are the vegetables that are left in the sieve, and the filtrate is the water that passes through the holes in the sieve. Now this is very similar to a coffee sock. Now this is the one you see in the kopitiam, where they pass coffee powder or coffee beans. They put it in the coffee sock and they run hot water through it. Now the filtrate is soluble coffee water or soluble coffee. The filtrate is not water. Okay, because what comes out is brown coffee. It is not colorless water, so filtrate is not water. Now this is the same as the tea bag as well. Now, some of you might ask, how about if we drink Nescafe? Now, Nescafe is totally soluble, so we won't have a residue here, unlike the ones in the coffee shop. Now, this is an interesting one. This is the last point in your table. Now, for those of you who are familiar, this is a old vacuum cleaner. So if you think about the vacuum cleaner, what exactly is the residue in the filtrate? If you're looking at the bag, what actually goes into the vacuum cleaner bag? Now, of course, there will be dust, right? Now, this dust does not come out of the bag. Otherwise, there will be no point in having a vacuum cleaner. Now, what actually comes out of the bag? Is it like water? We don't really have water on the ground, right? So in this case, the filtrate is not a liquid. The filtrate in this case is air. So this is to highlight that the filtrate doesn't have to be water or liquid. It can be a gas as well. And the residue will be dust, as we just mentioned. Now, other uses of filtration, if you look at this giant cow, so our nostrils have lots of nose hairs to trap dust. Now, this is not embarrassing because all of us have all these things so they can trap these, and those of you who have seen people dig their noses, then you will see the dust come out because it does trap dust and it allows clean air to go into our lungs. Our kidneys as well function as a filter. It retains the nutrients in our body and it passes out yellow urine. Now, very important use of filtration, as I mentioned earlier, is to filter water. Now, globally, about 1 in 9 people don't have access to safe and clean drinking water. So we are actually very, very blessed in Singapore to have safe and clean drinking water. Now, I want you to guess what this is. If you observe, it's actually a life straw. But what is a life straw? We'll find out in the next video.